Hey guys, welcome back to the shop. So we recently worked on one of these cart top fixture plates right here, and in that video that I shared, I showed that I was having a problem with the rigid tapping cycle here on the Flex CNC. That problem has since been fixed. I even talked about that at the end of that last video. The software engineers team viewed into the computer there, and there was an adjustment that they had to make in the computer software, and that's all the problem was right there. We did some test runs on that sample piece I showed in that video, checked it with the thread gauge, and I think we have really good tapped holes now based off that test piece. So I am ready to go ahead and work on the second fixture plate here and get it done, and hopefully we're going to have some beautiful threads at the end. The threads on that test piece look like they were absolutely beautiful, almost like a ground thread in there. They were so pretty. So I feel confident that we can run through this program now. We shouldn't have any issues now. So that's what I'm getting ready to start on. And we showed a lot of video of the last one being cut, so that's not really what I'm wanting to do is show a bunch of the machining. I think I'm just kind of talk you through some of the segments as it's happening. I saw in some of the comments that there was some people that said that maybe there's some people that's learning. There's always people watching that are trying to learn this stuff, and I love trying to share the things that I've learned and the things that I know with my viewers, so hopefully that I can carry that message over to them and they can take that into their own work of understanding. But please understand, and please remember that when it comes to the CNC stuff, I'm still new at this, still very new, and I'm still trying to learn this myself and figure this stuff out. Thankfully, I've got some good friends on my side that's been helping me, like Kevin over Mechanical Advantage. Him and I get together every week and do a little bit of training on possible projects that I have coming up, jobs that I quote people that don't even necessarily get approved, but offers me a good chance to go in there and practice on a separate workpiece that I haven't done before. So that's really helping out. So Kevin's a huge help with my Fusion 360 training. So thank you, Kevin, for that. And I think what I want to try to do through this is maybe kind of relay a little bit of that information of what we're doing, what the machine is doing, and relay that over to the viewer that's watching there, okay? I know it's a little hard to see. One of the problems with the Flex CNC is just by design, it's really hard to get good video in there, especially if you're using flood coolant. We need to use our flood coolant because we need to protect our tools, but the way that the coolant system operates, the flood coolant in the Flex CNC is that you create a lot of windage in there from the spindle, so it kind of, you know, atomizes a lot of that coolant, and it's hard to see what's going on in there. So we'll kind of stand out to the side a little bit, and I'll just talk you through some of the segments as we're getting in there. So in case you didn't see the previous job here that we did, this is a cart top for a flex arm cart just like that right there. So it's got a series of 1/2-13 tapped holes in it. We have the mounting holes where the flex arm pedestal bolts down, and that's a series of 3/8-16 holes. And that's pretty much it. We also have our 4 mounting holes on the outside. That's a 9/16 drill, and then we use a 1/2-inch end mill to counterboard that. So it looked like this right here. You know, you got a socket head bolt that goes in those holes that bolts it down. And other than that, 1/2-13 and 3/8-16 tapped holes. Here's a look at the screen. This is where our program is. The very first few lines shows our tools that we're going to be running. So we have a 9/16 drill, 5/16 drill, 27/64 drill, which is tap size for 1/2-13, 1/2-inch flat end mill, a 3/8 diameter chamfer mill, 3/8 tap, 1/2-inch tap. That's all it is right there. It takes approximately an hour to run through this program because there's 216 holes total in this job here. So I believe we're ready to go ahead and get started on this, and we'll just kind of walk you through the job as it's happening. All right, I think we're ready to go. So on this controller here, this runs along that rail down there. So you can pull this controller anywhere you want. It rotates back and forth there as well, but you can see you can just kind of pull it where you want it. So we'll be kind of working in this general area right about here. And we'll go ahead and start this program. Everything should be good. That's our G56, yeah, 54.5, and this is G56 work offset right here. All the tools should be still good to go. We haven't changed anything there. Now we do have some alarms here. Let's go to that. So that's from where I've been in there. I was cleaning that that screen off in there so we could see it a little bit better. So trip those barriers, you just have to do a reset right here. Everything's reset, no alarms. Now we go back to auto mode, which is going to be our actual program, and we just hit cycle start. Now it's going to do a tool change to our 5/16 drill, tool number 14. And I'm going to come right over here. And so this is our feed rate control right here, this little knob. And when we first start these programs, it's really good practice to have this turned way down so you can kind of watch this tool come down and make sure that we're in the right spot. We're not going to crash or anything. So I'm going to have my right hand on that. See, I'm turning it. You see we just slowed it down. I think I cleaned that, yeah. All right, so get over here. All right, so it looks like I'm speeding it up, and we're gonna slow it down here just to stop, so you can turn this feed rate all the way down and it won't move. But I can just visually see that we're in the right location there, so we should be good to go. This is our Walter 9/16 carbide drill. I absolutely love using these solid carbide drills. You can see just how fast they can feed through material, and I don't even have it at the fastest speed you can run these guys. So that's what, I don't know, 2 or 3 seconds worth? 1, 2, 3. How about 3 seconds per hole? So now we're going to come down here to a tool change for tool number 12. That's going to be a 5/16 diameter drill bit. Oh, we got to hit cycle start. So I have optional stop set on this for this case right here. Once it gets to a tool change, you have to come up here and hit cycle start. That way, if you want to check things out or whatever, right? Like right now, I can change this over here to manual mode. All right, let's just do that. We can change the manual. Then we can open up this door. Otherwise, if you open it during the program, it would alarm and it would stop everything. So you can get in here and you can do some inspections. How's our holes look? I think they look pretty good. So we'll go ahead and close her back up. You see you've got a sensor here. That's why you gotta, it knows everything you're doing. You have a laser there, you got a laser curtain out here. You gotta be careful. So we'll go back over here to auto. All right, and then we're just gonna hit cycle start. Now you can turn this off by just pushing optional stop. Cycle start. So you can use the mouse or touchscreen on this. So let's swap over to our 5/16 drill, and we'll drill those 8 holes. It's like a circular hole pattern for the flex arm base. I feel good about the work locations. All of our tools should still be just like we had them, so I'm not going to worry about the feed rate knob here. So this is our Walter Tools 5/16 drill bit, tap size for a 3/8/16 hole. Look how fast it goes through that. About 1.5 seconds per hole. All right, so another issue that's happening there is the coolant's coming down through the collet. I've had plenty of comments telling me that I need to run sealed collets, and I'm aware of that. I just haven't taken the time to get some sealed collets in here. That's something on my to-do list, is get some collets that are sealed so that all the coolant is going down just through the center of the tool for our through spindle coolant. So we're gonna hit cycle start so that we can go to our 27/64 diameter drill bit next. Okay, another Walter Tools drill bit here. 27/64 is our tap size for our 1/2 13 holes. So there's 200 How many is that? Trying to do the math in my head. Can't think of it right off the bat. You guys probably know. But anyway, we got a bunch of holes to drill right here. And you see just how fast it's going down through there. 1, 2, so 2.5 seconds per hole. And again, you can change that feed rate. Once you really know how good a tool is going to work, in my case, I'm learning, you can really kick that feed rate up to the high end of what the manufacturer will recommend for it. And you can blow through these workpieces even faster. Those drills do such a good job. And you can see our code there. This is just for the folks that are learning. This is our G code. It's just going to those X dimensions, X being this way, left and right on the machine. And it's just going to those coordinates, which is inches based off of our program, off our workpiece coordinates. You got to be real careful not to get close to that curtain screen right up there, but also that laser that's down there, because it's shooting this way. That cord really doesn't affect it much. You can see that it's not really bothering it, but if I stand too close right there, it can tell that I'm getting right there at the machine. So 204 holes is what I'm coming up with in my head that we're drilling right here, plus the other 8, plus the other 4, that's 216. The Flex is really suited for this kind of work. It's really, where it shines is having this big open table here for you to be able to work on these larger workpieces like this. You know, unless you have a machining center like the Miltronics that's big, you got a big table with lots of travel. The Flex really shines when it comes to these large workpieces. You know, if you've got some plate steel that say, you know, standard sheets are like 4x8 or 4x10, you could take a full sheet of plate steel, 4 foot wide, and set it on this machine and go to town doing just what we're doing right there. If you got holes to drill in it, tapping holes, if you've got slots and things to mill in there, that's where these gantry type machines really shine, is those large workpieces like that. Coming back to our code, you can see line 115, it says Y -5 right there. That was our Y movement over to the next row of holes. And now it's just moving in one linear motion on our X-axis. So again, I'm just kind of going over some of this stuff because we have people that are new, that don't understand what's going on here. So I'm just trying to relay a little bit of that information to those folks that like to learn as we share the video here. I absolutely love those drills, man. Growing up in the job shop and working on our manual machines here, these mills like this, we really didn't use carbide very much. We mainly just used high-speed steel. So getting to jump in here on our CNC machines and use those carbide drills and be able to blow through those holes as fast as we are, it's very satisfying to be able to watch that. So while that's drilling those holes, I can show you this little part right here that I was just working on. This is just a sample. This is not anything that's going to be a part. The only thing that I was doing here was trying to practice machining like a 3D surface here. This, what I call this cone shape. We did this over there on the Flex. And I have a possible job that might be coming up. If it ends up getting approved, we have some large aluminum discs that are 1 inch thick, about 21 inches in diameter, and on one face, one side of it, it actually has a taper on it like that. And I wanted to go ahead and give a little test program over here on the Flex. This being the first time that I've machined something like this, other than a little bit that we did at John's shop during that training session up there, fusion training. We did a couple little parts where there was sort of like a 3D surface on there. But this is the first time I've done it in my shop. You can, if I hold it up there, you can kind of see. and it did pretty good. Now that was a mistake. You see those cutouts there? That one right there is where I actually stopped the machine because I realized that I didn't have my Z offset. What I was doing was I was bringing it down so I could recut it, and I messed up and put the wrong dimension in there, and the cutter came down here and went way too deep. So I adjusted it and just finished it and left those little scallops in there. But anyway, that's what we might end up doing over here on the Flex if that job gets approved. I'm probably going to have a couple of big steel fixture plates, just some cutout, some 1-inch plate steel that I'll have the welding shop burn, and we'll set them up here just like that, drill some holes in it and do some milled features on there so that we can bolt our fixtures down to the bed rails, and then be able to take the aluminum disc that we're going to be machining and set them down in there. And there's going to be two ops. One, we'll clamp it on the outside so that we can machine the center portion of the disc, and then once that's done, we'll take it out of one fixture plate, set it over in the other where it's going to center up on it, clamp it on the inside, and then machine the outside of the disc, and then put this bevel portion on it there as well. So it's just something that could be coming down the pipeline very soon if the job gets approved, and if it does, I'm going to have a lot of machine work to do, and we'll be able to share that project with you. Right now we're at right at 11 minutes. So once we get all of the holes drilled, I can't remember if we do, yeah, I think the next one's going to be the counter bore, and we'll counter bore the 4 bolt down holes, and then we'll come back and chamfer all the holes. By the way, we finally officially hit summer. It's been hot every day. I know everybody's getting hot. I love having my big ass fan in here. I always kind of keep it right in this area and turn it on so that this moves so much air through the whole part of the shop right here. Now, I don't really talk about this much, but I've got one air conditioner on, that mini split there. I've got 4 of them total. We got 2 of them there, and we got 2 back there. Now, I have run all 4 of them in the middle of the summer before, and jumps the power bill up quite a bit. I'm trying to get myself comfortable with just having 1 unit on during the day, and it keeps it comfortable in here. Now, it still gets warm because it gets pretty hot up there. If you get up on the top right there, it's pretty hot. But I'd say, I don't have a thermometer out here, but it's probably 78 to 80 degrees out here right now because the sun's shining, it's hot outside, but it keeps it comfortable. You got the big ass fan that you can move some air around here. You can stand here in front of it and it just feels so much better. But I've just been running 1 AC, and it does keep it comfortable in here, and it keeps the power bill down a little bit where it's not, you know, you're not running 4 ACs, because I actually got another one in the office in there that I run too. I keep it set on around 72 to 74 degrees. This is where I have to be really careful not to get in the side of that laser there. Where it messed me up before is because I was walking that way going into it. It'll give you a certain amount of seconds to get out of the way before it stops. It's supposed to slow down, but I was like walking into it. That's why it stopped that time. So we're on our last row of holes right now, our last half 13 holes. There's a little bit better look at it. Looks like we got 5 or 6 more there. Last hole. Now we're going to come up and do a tool change. So to go up to Z0 there for a safe tool change position. And we got to hit our cycle start to start the next tool. Now we're going to our flat end mill, which is going to make the counter bore on the 4 corners. It'll look like this right here. All right, so this is our 1/2 inch IMCO brand 6 flute carbide end mill, running in a Heimer shrink fit holder and flood coolant. And what it's going to do is it's going to do an interpolation to cut our 9/16 diameter holes to the diameter that we've got programmed for that counterbore to be. So it should be, it's just over 1/2 inch deep, and I believe just a little bit over 3/4 in diameter. It's a little chattery on those two out there because that fixture is hanging off. This is a little more rigid there. So it just goes right down to the center of that drilled hole, and it just does a spiral pattern until it gets to the diameter that we want that hole to be. That Imco end mill is doing a fine job too. Of course, that's our code that it's reading to make that circular pattern right there. And it'll move over to the last hole right about here. So you hear that ringing out there? It's because that bar doesn't go all the way to that other rail and support it. So it's got a little bit of vibration and chatter over there, but it's okay. All right, that should be finished up there. Now it's time for a tool change. We're going to be going to tool number 4 to our 3/8 diameter chamfer mill. So what this tool is it's a mill drill. It's what I've been using as a mill drill. So you can use it to spot holes, chamfer, you can drill holes with it. It's a pretty versatile tool. You can even side mill with it if you want to. I use it mainly for spotting holes where we got to drill a hole or chamfering the holes. All right, chamfering holes. I think we're going to start on that back corner. No, we're going to do that's the 8 3/8 holes that it's going to do there. I believe this one it's just going to come down like a chamfer tool. I'm sorry, a countersink tool. So it'll come straight down, cut the chamfer back up, move to the other holes. All right, now we're going to be cutting the chamfers on the 1/2 inch diameter holes. So just like the end mill, it just comes to the center of the hole and it spirals around and cuts the chamfer. Again, you can kind of hear that chatter on that back side because of the 2 fixture bars, or the 3, I'm sorry, hanging over there. That particular tool path, it kind of chose a different direction, a different pattern to follow versus the drilled holes. You know, our drilled holes was just doing a back and forth linear pattern. For whatever reason, the program, it optimizes to make it the fastest route, but it decided to go this way and it kind of moves around a little bit. But you can kind of hear that it's more rigid over here on this side, because our 3 bars are bolted down to these 3 rails right here. Really nice way to make a chamfered hole there. Back to our manual days, you know, you usually just use a countersinking tool and come straight down the center of the hole and cut it all at one time, where CNC style, you go around the hole. We are just about finished with our chamfering. Right now it's chamfering the 4 mounting hole locations. Make sure I don't trip that alarm there. Alrighty, chamfer's done. We're at almost 38 minutes now. So we're gonna go next to our 3/8/16 tap. Hit cycle start. Ready to go grab our tap. I would have, you know, what I should have done was stop it right here using that optional stop and clean this off right here. All right, 3/8/16 tap. We are using a spiral pointed tap, so it's gonna push the chips down because we are a through hole. I know it's a little tough to see. This is where maximum pucker factor shoots up to an all-time high. All right, I don't hear the squeaking sound, so it doesn't sound like we're pulling the thread like last time. I think we're doing good here. Let's see if we can get a little better shot through this side. Rigid tapping is always, I think it's probably the same for everybody, unless you're a seasoned CNC machinist, you get used to it, but you're always wondering, is it gonna line up? Is it gonna snap off in there? I think we're doing good though. Our flood coolant works really good for those low RPMs like that because it's not spraying it out. All right, so we're gonna do a tool change here. Now we're gonna change to tool number 7, which is gonna be our 1/2-13 tap right there. So before I hit cycle start, I wanna go ahead and clean that window off so we have a little bit better view through there. All right, window clean. How's the holes look? Give us a progress report. All right, I'll check them out when we're done here. Much better. Okay, we're gonna jump back over to auto and continue on. We'll go get our 1/2-13 tap and get all of our, what did I say, 204 holes to tap. And that'll finish it out. So that's gonna take approximately 20 minutes to do. So here we're using a Walter tap. That's a 4-flute spiral pointed tap. And it's been doing a beautiful job. All right, here we go. Pucker factor high again. Sounds good. You got the little squeak going in, normal for cutting, but you're not getting that squeak coming out, so it should not be pulling on those threads now. Fingers crossed, we've got some good holes there. You can see our code. Let's just go into all those X locations, which is your hole distance there. I have to move because the mill and the toolbox is so close right there. Now you also hear that auger down in there too. You can see it rotating, so you get those long stringy chips, and it just makes that little chattery sound because those chips get caught up in those fins. But it pulls them down here, and there we have our chip pan right there. In case you were wondering about an RPM, I believe we had that set at 340 RPM. You can see it right here. This is your speed. S is spindle speed. TC is your tool number, so we're running tool number 7. And of course that's your Z movement there, that's your spindle up and down, your Z movement, and then the location of the XY coordinates. You can see X19, 19, X21, X21. That spindle, when it gets to that spot right there, it's got that little bit of a chattery sound. I'm assuming it's in the ball screw or something. I don't really know. It's not affecting the machine in any way, but you probably hear it in the video, so I thought I'd mention what it is that you're hearing. This is a nice spot, sitting right in front of the fan, getting some windage. So I did bring out I got a digital thermometer I keep in the office. I never bring it out here, but I did bring it out here for this. You can see where it looks like about 82 degrees, 55% humidity. That's probably gonna climb. It's only been sitting there a couple minutes. 82, it feels like it out here, but it's comfortable with the AC going. Helps pull a little bit of that moisture out of the air, the humidity. All right, so we're looks like about halfway through. We look like we just reached halfway point, and we are at 52 minutes. So we got probably about 7, 8, 9 minutes left to finish this up. All right, on the last row, and we got a few more holes, 59.5 minutes. We're right on that 1 hour mark. Let's see if we can watch these last few being tapped. There's the hole we're looking for. Gantry's gonna move down out of the way. And there we have it. So, how'd our holes turn out this time? So far, so good. They're looking pretty good to me. Trying to see any inconsistencies. All right, that's just chips in that one. How about our 3/8 holes? I think we have success this time, guys. I think it looks better. All right, so let me get this cleaned off. We'll get the chips off, clean all these holes out. There's one of our, let me see if I can do this without slicing my fingertips. No, it's getting a little tight. So let's get it cleaned off, we'll blow it off, and we'll bring you back and we'll do a little inspection with our thread gauges and see how they fit. Well, it's actually a little warmer in here than I thought it was. We're at 89 degrees right now, but it's in the middle of the day, 2:30. The sun's been beating on us all day long, no rain, so it gets pretty warm in here, but that's just with that one unit right there, keeping us cool and keeping the humidity at a comfortable level in here. All right, so we've got this is our go, no-go gauges here, our thread gauge. So we got a good fit. This is a 3/8 right here, there's our half. And then this guy right here is just a standard 1/2 inch stud, just standard hardware grade. We should be able to screw this guy down anywhere we want here, and it is. It's feeling good. Typically, you're either going to use studs like this or use a bolt to hold down your vices or any kind of fixture on these plates right here. So our threads look good, much better improvement over the first one that we did. I'm really happy that Flex was able to get in here on the controller and make a tweak that they needed for that rigid tapping cycle. And I think we're good to go now for all of our tapping. So other than getting this guy out of the fixture here, this guy is finished up. All right, guys, well, that's gonna wrap up this project. I was happy to get this second fixture plate done. We've got a successful piece there, and our machine is threading, rigid tapping like it should, and we're good to go. So we'll just get this guy loaded up on the pallet and get this shipped back up to Ohio up there at Flex Machine Tools, and they'll be using that on one of their Flex arm carts. So I wanted to use this as a nice little training and practice session, and we're good on that. So now I've got to actually get in there and design a program that's going to do, I've got a bigger cart top, which is going to be for that cart right there. So that's a bigger plate. So it's going to be pretty much identical to this, except they've actually got it designed where the flange mount is mounted in, you can mount it in 3 different locations. So there'll be, I guess, 24 of those, whatever size hole we're going to put in the other fixture plate. There'll be 3 of those locations, and all the rest of them are half 13. And then I think there's 6 of these counterboard holes versus just the 4. So I'm going to be working on that pretty soon, getting on Fusion and start laying that out. A really good practice session for me there. And now that I know that this is ready to go, I'm ready to get started on it. But I got some other jobs, as I mentioned at the beginning of the video, hopefully coming down the pipeline if the customers are going to approve them, and we'll have some pretty big projects to work on over here on the Flex, okay? I was trying to talk through a little bit of the machining cycles and, you know, the tools and what they're doing and what we're looking at on the screen, just for some of those people that were asking out there in the comment section. So I was trying to be helpful, and I hope that I was helpful to some of you guys. I know the guys that are doing CNC machining, they know all this stuff that's going on, but we are trying to help the others that are learning in the trades here. So that's all I'm trying to do, is share a little bit of what I know and what I've experienced and what we're doing over here on the machines, okay? So guys, I hope you enjoyed the video. Got plenty of work ahead that we got coming. For those that are concerned about we're not seeing any manual machine work, I've said before, we're still doing manual machining. I've got manual machining projects, I've got CNC projects. You're gonna see a mixture of the both. You know, one week we might have a CNC, the next week we might have a manual, you know, or maybe a couple weeks of each. You know, I just, whatever's coming through the door, whatever I'm working on, those kind of projects, customer projects, viewer-based projects that come in the door, I just try to share everything with you. So you're gonna have a mixture of both CNC and the manual stuff there as well. All right? So hope you enjoyed, and I hope to see you on the next video.